So welcome back once again to the online classes of class 10. We were discussing the problems regarding acids and bases. We are going to do the same. So we are going to discuss the problems regarding acids and bases. Acids and bases and salts. All of this. Now, let us solve the first problem for today. So these are the NCERT problems, okay? First problem for today is, the question is, you can see it from your book itself. The first question, let me tell you the question number. It is the question number 10 that we are going to solve right now. So as per the question number 10, the question is, equal lengths of magnesium ribbons are taken in test tube A and B. Carefully see. So there are two test tubes. A and B. And in both of these, magnesium ribbon is taken. So suppose this is the magnesium ribbon. Suppose this is the magnesium ribbon that is present in both of these. Here also. It is of equal length. So this is magnesium ribbon. Now, in first case, we take HCl. So here it is mixed up with HCl. And in the second case, we are adding acetic acid. So here it is acetic acid. So test tube A, test tube B, here HCl and magnesium ribbon. And in the second case, acetic acid and magnesium ribbon. The question is, in which test tube the fizzing occur will be more vigorous. Now we know that when magnesium reacts, let us see the reactions first. When magnesium reacts with HCl and when magnesium reacts with acetic acid. By the way, it is question number 10. So here we can get MgCl2 plus H2, and here it is 2. And here we will get magnesium acetate, that is CH3 CO2 whole twice Mg plus H2, like this. What does it mean? It means in both the cases hydrogen will be evolved, and due to the evolution of this hydrogen gas, the question of fizzing is coming over here. I hope you have understood. Because in both the case hydrogen gas will be evolved, that is why the question is there. The question has been written as, in which test tube the fizzing occur will be more vigorously. But as we know that among both of this is a strong acid. And because it is a strong acid, that is why this reaction will be much faster compared to this reaction. This will be slow. So that is why in this particular case, fizzing will be vigorously fizzing. In which case? In the first case. So that will be the answer of the first question. Now let us look into the question number 11. In question number 11, you can see the question from your book itself. That is why I hope I don't have to write the question once again. The question is, if fresh milk has a pH of 6. So according to the question, fresh milk is having a pH of 6. Now question is, how do you think the pH will change as it turns into curd? Explain your answer. So if the milk converts into curd, then what will be the value of pH? That is the question. So what do you think? What is the nature of the curd? Obviously, the curd is acidic in nature. It contains free lactic acid. So the pH of the curd will be lower than that of fresh milk. Remember, in the curd, whenever it is prepared, it is having the lactic acid. So curd is having the lactic acid, so it becomes acidic in nature, and the pH becomes even lesser. So it becomes lesser than 6. So that will be the answer of the question number 11. So next is the question number 12. The question number 12 is also a descriptive type question. I am reading it out. You also carefully see to it. The question is, a milkman adds a very small amount of baking soda to fresh milk. So what he is doing is, a milkman is adding, that is question number, that is 12. So milkman is adding baking soda to fresh milk. That is the activity. Now the question is, why does it shift the pH of the fresh milk from 6 to slightly alkaline? Baking soda, as we know, will convert the milk into the alkaline form. So the answer will be, again I am telling you the question, you can see it from the book though. The question is, why does the milkman shift the pH of the fresh milk from 6 to slightly alkaline? See, the answer will be, remember, during the storage of milk, remember, milkman has to keep the milk for a longer amount of time. So during the storage of milk, the milk becomes slightly acidic. So it becomes slightly acidic. So what happens is, जब milk को ज़्यादा time तक एक जगह पे store किया जाता है, तो it becomes slightly acidic. It becomes acidic in nature. So now, when baking soda is added, when you are adding baking soda to it, which is sodium bicarbonate, as a result, so when baking soda is added to this slightly acidic milk, the neutralization takes place. This is called neutralization, and due to this neutralization only, it remains okay. So again I am repeating the situation. What happens is, initially when the fresh milk is taken, milkman normally adds baking soda. The reason is, milkman has to keep the milk for a longer amount of time. So during the storage of milk, it becomes slightly acidic in nature, and to neutralize that acid, he adds little amount of baking soda. I hope it is understood. Now, this is the first part of the question. This is only the first part of this question. The second part of this question is, why does this milk take a longer time to set as curd? So, why does it takes longer time to set as curd? So that is also a very interesting question. It is usually seen that when sodium bicarbonate is added to the milk, it takes a little bit longer time to become curd. What could be the answer? The answer is, the enzyme which converts milk into curd is active only in acidic condition. So the acid produced during the curd formation first neutralizes the base present in the milkman's milk. So the answer, as I have said, that you have to convert the milk to curd, right? So if you want to do that, if you are trying to convert the milk to curd, you need to use certain bacteria. Certain bacteria is actually responsible for that, and it is only active in acidic condition. So only active in acidic condition. So as a result, when it becomes, after adding NaOH the acidity will be neutralized. So it is not acidic anymore. So when it is not acidic anymore, the bacteria will be comparatively ineffective. So it waits for the milk to give rise to more acidity, and the little amount of NaOH first it neutralizes. शुरू में जो यूज किया गया था वो तो ऑलरेडी न्यूट्रलाइज कर चुका है. फिर से मिल्क को अगर ऐसे ही रखा जाए तो फिर little amount of more acid will be generated, and at that condition only this bacteria will be activated. So the moral of the story is, to convert milk to curd, you need to have the active acidity medium so that the bacteria can be activated, जो कि सोडियम बाइकार्बोनेट ऐड करने से नहीं रहता है. That is why the neutralization takes place after adding sodium bicarbonate, and during that condition the bacteria will be ineffective. Now let us look into the next question. That is question number 13. Question number 13 is, plaster of Paris should be stored in a moisture proof container. Question is why? So I think we all know the formula of plaster of Paris. By the way, this is question number 13. Question number 13. Plaster of Paris, CaSO4 and H2O. Either you can write like this or you can write like this, CaSO4 half H2O. If you are adding water to it, what happens is it becomes CaSO4 comma 2H2O, which is gypsum, and this one is POP, that is plaster of Paris. So what we have observed is the addition of little bit of water makes it gypsum, which is hard substance. So that is why it is expected that whenever you are using plaster of Paris, you should keep it in a moisture proof container. Now the next question is, what is neutralization reaction? Give two examples. So obviously we all know that the neutralization reaction is the reaction between the acids and bases. So let us see two examples. Neutralization reaction. So let us see two examples. Obviously the first example I can write is very easy. Sodium hydroxide plus HCl gives rise to NaCl plus water. Neutralization means base plus acid gives rise to salt and water. This is one. Another you can write same thing. You can take sodium hydroxide and sulfuric acid, NaOH plus H2SO4 you can take. In that case we will be getting Na2SO4 plus H2O. So in that case I think you have to use 2 over there. So this is the case. These two are very good examples. I think here also you have to use 2. So these two are the very good examples of the neutralization reaction. The last question is, what is the use of washing soda and baking soda? So just I am telling, I am not writing it down, okay. So washing soda, as you know, is used for washing clothes. Or rather, let me write it, it will not take much time. Question is uses of washing soda and baking soda. So for washing soda, washing soda is used for washing clothes, and It is also used for some compounds like borax, etc. For, you can write, for manufacturing of borax. Next is for baking soda. So baking soda, we know that it is used for different kind of drinks which is having effervescence. So for baking soda, or very easy, used in cakes to make it fluffy, इसको फुलाने के लिए, because it generates carbon dioxide. And the second one is used in cold drinks to generate effervescence. So these are some common examples. So with this we have concluded the NCERT problems. Now we will solve one or two problems which is coming from outside NCERT. So maybe that will be comparatively more complicated and a little bit unknown, but let us try to solve those. So the first problem like that, I'm just writing the question because this question is unknown for you as well. So the question goes like this, carefully see. A metal carbonate X on reacting with an acid gives a gas which when passed through a solution Y, solution is Y, gives the carbonate back, On the other hand, a gas G termed as G is obtained at the anode, during electrolysis of brine, is passed on dry Y. It gives a compound Z, which is used for disinfecting drinking water. So, which is used for disinfecting drinking water. Identify, question is identify X, Y, Z and G. Big question that is, metal carbonate on reacting with an acid gives a gas. which when passed through a solution Y gives the carbonate back. So we can write down the first part, that if I take a metal carbonate plus acid, it gives rise to formation of a gas which when passed through solution Y, this will pass through a solution Y, it will give back the carbonate. It will give back the carbonate. On the other hand, a gas is obtained, gas G is obtained at the anode during electrolysis of brine. So brine, as we know, brine is a solution of sodium chloride. So let us write down that first. So brine I take, let me write in black only. So we have taken brine, which is of, say on the other hand, a gas G is obtained at the anode during electrolysis of brine. So brine is electrolyzed. Brine, it is electrolyzed during electrolysis of brine is passed on dry Y. So brine is electrolyzed and it gives G at anode. It gives G at anode. Then when it is passed on dry Y, it gives Z. So it is passed on dry Y, it gives Z. Now what is the job of Z? Z disinfects the water. Disinfects the water. So this is the whole story. Do not lose the track. Carefully see. A metal carbonate is taken where an acid is added. It gives rise to a gas which when passed through Y, it gives rise to carbonate. And on brine, if you are using if it is electrolyzed, G will be produced at anode, and G is a gas, by the way. It is a gas here. It is produced at anode, and when it is passed through dry Y, it gives rise to Z. So carefully see. We know sodium chloride, if it is electrolyzed, it will give rise to chlorine gas. Brine means sodium chloride. If it is sodium chloride, on electrolysis, it will give rise to the production of chlorine gas. Now chlorine gas, when it is passed through Y, it gives rise to Z, which disinfects the water. We know which one disinfects the water. It is bleaching powder. So it is CaOCl, Cl. This will be the answer of this one. So remember, we have to pass chlorine through such a Y which will disinfect which will produce Z. So here the answer on this part will be CaOH whole twice, which is called Slake line. So let me write Slake line. I hope this part is understood. Brine electrolyzed, chlorine gas will be produced at anode, and obviously sodium metal will be produced at cathode. Now on passing the chlorine gas through Y, which should be dry, we are getting Z, which disinfects the water. So whenever this term is coming, disinfecting the water, obviously bleaching powder should come in our mind. So Z should be bleaching powder, G should be chlorine, and this Y, this is Y actually, this should be CaOH whole twice. Now metal carbonate reacts with an acid passed through a gas, gives a gas, which when passed through Y gives carbonate. So we all know that when the metal carbonate reacts with an acid, what happens? On reaction of metal carbonate with acid, it gives rise to the formation of carbon dioxide gas. So this gas should be carbon dioxide. We know that in our mind. So carbon dioxide, when it is passed through Y, obviously carbon dioxide when it is passed through calcium hydroxide, it will give rise to the formation of carbonate. Which carbonate? Obviously it will give rise to the formation of calcium hydroxide on treatment with calcium carbonate, which we all know that it produces calcium carbonate. So what? So this one is actually CaCO3. So it becomes little bit clumsy over here. I would like to repeat once again. Brine electrolyzed, on anode it produces chlorine gas. Chlorine gas, when it is passed through a dry Y, it gives a disinfectant. So obviously disinfectant is bleaching powder. So chlorine, by passing through which will produce bleaching powder, obviously that should be solid calcium hydroxide, which is called slackline. Now metal carbonate when reacts with acid, it gives rise to carbon dioxide gas. Obviously that carbon dioxide gas on passing Y we have already calculated, which is slackline, gives rise to calcium carbonate. Very quickly let us see the reactions so that it can clear our doubts further. These reactions let us write down. So first thing first is, if we take sodium chloride, suppose we are writing sodium chloride, this one, it is electrolyzed, so obviously it will react with water also during the process of electrolysis. It produces sodium hydroxide plus chlorine gas. So it produces sodium hydroxide plus chlorine gas. Now this product produced chlorine, this one, further reacts with calcium hydroxide and it gives rise to the formation of bleaching powder, CaOCl, Cl. And along with that, water is also produced. So this is the first and second part. This is the first part and this is the second part. Now let us come to the third part. Third part is metal carbonate reacts with acids. So let us choose any metal carbonate, but in this case metal is calcium. So without any complication, let us choose calcium carbonate only. It reacts with HCl because it reacts with an acid to give rise to carbon dioxide gas, plus, as you know, along with carbon dioxide, in case of calcium carbonate, along with carbon dioxide we will be forming calcium chloride and water also. Now let us quickly check the balance. I think it is fine. Now this carbon dioxide on treatment with Y becomes, Y is already detected, so carbon dioxide on treatment with calcium hydroxide, which is Y, gives rise to the formation of calcium carbonate plus water. Here, if we check, so this will be G, where it's chlorine gas, this one is G. Then on treatment with Y, that is calcium hydroxide, so this is Y. Calcium carbonate reacts with HCl to produce carbon dioxide, which further on treatment with Y, this is Y once again, gives rise to this one. You see, this one is also, sorry, not this one, this one. Calcium carbonate on reacting with acid, it becomes a gas. The gas is carbon dioxide. The gas on treatment with Y, which is calcium hydroxide, gives rise to metal carbonate back, which is calcium carbonate. So this is the whole story. Just I am rewriting this part once again. Carbonate, that is plus acid. So this is the total story. Very good question. Carefully see. Brine, NaCl. Electrolyzed water is used. Produces chlorine gas. Okay, so chlorine gas will be G. This one. Now chlorine gas on treatment with calcium hydroxide gives rise to bleaching powder. So Y should be slaked lime, which is calcium hydroxide. Now go back to the first case. Metal carbonate on treatment with acid gives rise to carbon dioxide. And since we have seen already the calcium case, so calcium should be that metal. So it gives rise to carbon dioxide, calcium chloride and water. Now that gas on treatment with Y we have already detected, that is calcium hydroxide. So carbon dioxide on treatment with calcium hydroxide gives rise to metal carbonate black, which is calcium carbonate. Very good problem according to me. Everything is written on the whiteboard. You carefully see to it. Little bit of harder problem, but I think once you see this kind of problem, you will be definitely able to solve it at the time of examination.